Hello, my name's Barry Quinn, and this is a 3-minute overview of our UK Fin Plus feasibility study on AI for regulatory compliance. I'll cover what we tested, the three results that matter, and what we delivered and will do next. The feasibility study had four objectives. First, assess whether AI can reliably extract structured rule graphs from regulatory text. Second, compare distinct architectural strategies under a unified evaluation. Third, test whether model confidence can support safe triage and design alternatives when it cannot. And fourth, develop transparent, reproducible evaluation infrastructure. We developed this work in collaboration with Funds Access, a fantastic Belfast-based fintech company, grounding the research in operational reality. We actually evaluate 7 AI architectures, or AI systems, on a canonic 36 rule test set, derived from European fund classification rules. 6 are LLM-based architectures spanning the design space, from few-shot prompting, retrieval augmented generation, hybrid symbolic validation, schema constrained generation, chain of thought interpretability, and ambiguity aware routing for production governance. The 7th is an independently developed neurosymbolic benchmark, comparing a curated graph DB knowledge base with embedded based retrieval. We score structural accuracy, vocabulary alignment, and confidence calibration under a conservative evaluation regime. So, we discovered 3 results that matter for real deployment. First, the vocabulary trap. Several neural and hybrid systems produce structurally sound graphs but drift in terminology. The output looks plausible, but non-canonic terms break downstream querying. And integration. Vocabulary consistency has to be treated as a first-class engineering requirement. The second trap is the confidence trap. In multiple architectures, confidence is inversely related to correctness. Systems can be most confident when most wrong. In decision theoretic terms, that makes confidence-based triage actively unsafe because it cannot route the most error-prone cases into automation. Third, the governance solution, graduated automation. Route rules by text ambiguity, not model confidence. Automate low ambiguity quantitative rules, require human verification for medium ambiguity rules, and preserve human-led encoding for high ambiguity provisions. So, the feasibility study itself delivers 4 concrete outputs. A reproducible evaluation pipeline with transparent canonicalization rules, a canonical benchmark dataset of 36 EFC rules with gold standard graphs suitable for future benchmarking, comparative evidence across symbolic, neuro, and hybrid approaches, a governance design with ambiguity aware, graduated automation, and a full written report documenting methods, results, limitations, and a route to production strategy. Finally, this project provides decision-relevant evidence for regulators assessing AI vendor claims and for firms identifying where automation is safe. We're now preparing a white paper targeting a top decision science journal and also developing Abhishek's own PhD thesis final chapter. We have secured an invite to present this at the FCA and are in follow-on discussions with Funds Access CEO Darren Burrows about moving our findings into some sort of prototype development. Next steps will focus on piloting graduated automation in the production setting to validate routing thresholds, and measure realized cost savings. Thank you for listening.